What if everything you know about how matter works is wrong? Physicists have stumbled onto something so bizarre that it breaks the very rules they spent centuries writing. In a quiet lab somewhere, scientists created something that shouldn't exist. Not because it exploded, or vanished, or broke their equipment, but because it simply doesn't fit the rules we thought we understood. It behaves in ways that seem to belong in science fiction, not in a chemistry textbook. For centuries, we've built our understanding of the world on a few basic ideas. Things are solid, liquid, or gas. They conduct electricity, or they don't. They're magnetic, or they're not. Materials follow patterns. They obey the laws of physics like students in a classroom, quietly, predictably, without rebellion. But this material, it doesn't raise its hand. It doesn't follow the lesson plan. It does things that, according to our best theories, should be impossible. Imagine a substance that can be both an insulator and a conductor at the same time, not switching between the two, but existing in both states simultaneously. Like a coin spinning in the air, never landing on heads or tails. Or picture something that responds to temperature in reverse. Instead of expanding when heated, it contracts. Instead of melting when warmed, it solidifies. It's as if the universe handed us a material that reads the rulebook backward. And here's the strangest part. It doesn't just bend the rules, it seems to ignore them altogether. Scientists first noticed something was off when they cooled this material down to near absolute zero, colder than outer space, colder than anything you'd ever encounter in daily life. At that temperature, most materials slow down, atoms barely move, electrons crawl. But in this case, something unexpected happened. Instead of freezing into stillness, the material became more active. It started conducting electricity with zero resistance. No energy lost, no heat, no friction, just perfect, effortless flow. That alone would be remarkable, but then they turned up the pressure, crushing the material between diamond anvils with forces that mimic the core of a planet, and under that pressure, it didn't crack or collapse. It transformed. It became something entirely new, a phase of matter that shouldn't exist under normal conditions, a state so delicate, so strange that it only appears when the universe is pushed to its limits. Now, you might ask, why does this matter? Why should we care about a weird substance that only behaves oddly in a lab at temperatures colder than Pluto? Those materials like this could change everything. Think about electricity. Right now, every time you charge your phone, power flows through wires. And along the way, some of it is lost as heat. That's why your laptop gets warm. That's why power lines hum. We waste energy just moving it from one place to another. But a material that conducts without resistance? That could mean power grids that never lose a single watt, trains that float on magnetic fields, gliding silently across continents, computers so fast they make today's machines look like abacuses. And it doesn't stop there. This material might hold the key to quantum computing, the kind of technology that could solve problems in seconds that would take today's supercomputers millions of years. It could help us build sensors so sensitive they detect the faintest whisper of a gravitational wave or the tiniest shift in a magnetic field. It might even lead to new forms of propulsion, new ways to store energy, new frontiers in medicine. But here's the catch. We still don't fully understand how it works. Physicists argue about it. Some say it's a new state of matter. Others think it's a doorway to something deeper, a clue that our current theories are incomplete, that beneath the surface of reality, there are layers we haven't even begun to explore. And that's what makes this material so extraordinary. It's not just strange, it's a mystery wrapped in a paradox, hiding in plain sight. It challenges what we think we know. It forces us to ask better questions. And maybe, just maybe, it's pointing us toward a future we can't yet imagine. So the next time you flip a switch, or charge a device, or wonder what's possible, remember, somewhere in a quiet lab, there's a material that shouldn't exist, and it's already changing the world. If you enjoyed this, hit subscribe and let us know in the comments what topic you want us to explore next. Thanks for watching, and we'll see you in the next one.